What are some of the, hey, there he is. Excellent, good to see you. What are some of the kinds of things that you've discovered simulating extreme weather to not to layman? What are some of the things that you learned?
Mark, I don't know exactly what's off this call. So glad we were able to connect and make everything work.
federal funding? Because this isn't like
Well, you have to verify. Yeah, they're authorized to use it. It has to go through a qualifier. So while we know this is new technology, we cannot use it until we go through all of the verification. Because, you know, the thing that is really exciting is the erosion of bridges and water, the rusting that this product is do, and the earthquake places. So it just is a nationwide.
So there are standards already that Beal has stuff to create for a certain level of standards. So it can be deployed. It is being deployed. This is the next generation of it. So based on this test, we'll modify the regulations, the standards, and then MDOT is looking at being able to deploy to the regulated. But then we're looking at get the next generation more with the carbon class.
Sorry, go ahead. What we're trying to do is to develop a guidelines. And the guideline also the software right now. And that's right now it's on the webpage. So any young engineer he will download the guidelines and they can download how to run it is on the webpage.
So it'll be a spec, and basically that's put in a bid. Okay.
So we're moving now from the higher diameter. So rather than using 20 diameter or 40 diameter for one beam, I can use this by 1/3. So we can start to see. So this is what we have
Why is it so important to have a break?
We're breaking because we
Sure.
need
Maybe for a second.
How long?
Can we move just a little bit over so they can get this on film for our online audience too?
So, you know, like celebrate break.
yeah, yeah. What's the breaking point? Yeah.
But how much
So did this start out straight and you're
look at the graph. So look at the deflection. And we are monitoring the force, deflection, strain, stresses, and the bridge. And actually we are monitoring 4 bridges for MDOT right now in the field. And through satellite system. 5 You see how much deflection?
incredible that it hasn't snapped yet.
Correct. The idea is if you have some problems in the bridge, you give me a motherboard, fix me. Hey, Andrew, how much treasure you have now? Speak to the microphone. So much? much, Andrew? 1,000 pounds. It's about 13 inch deflection. Actually, if I remove the load, it will go back to the...
Can you hear me okay?
Go back up.
We are currently at 155,000 pounds and 13 inches of deflection, which deflection is obviously what our beam has moved from the beginning. And we can expect our failure to be anywhere between 180 and 200. We're getting close.
The idea when you design this bridge has to give you enough walking to fix it and correct.
We're now at 160,000 pounds.
Now the student were debating if we should put the beam across to fill the bridge, and finally they said no. Load the middle beam rather than the entire bridge, and between the middle beam and other beam there's something called shear key. If the shear key is not strong, the middle beam will separate from the bridge and the shear key will fail. But as you can see here, the force is being distributed very well to the adjacent beams in such a way there is no separation.
We're at now 165,000 pounds, 14.8 inches of deflection. We're now at 170,000 pounds.
Do you have an estimate of when it will? What's your estimate? For 15.6, where do you, how far do you think it'll go?
175 should be down on the floor. But now exceeded what we calculated.
I know we have a little bit of a noise, but if you can hear, there is light cracking occurring already.
It's expected because the concrete with the curing and the carbon fiber has much more reserve capacity than what will be given by the machine. Because we designed for what has been guaranteed. But obviously it has more than guaranteed. Our expectation, carbon fiber strands, so the average option, the way they design one after the other, and all here. Then it will, of course. And then the concrete will be crushed. The concrete at the top, crushing the
175 kips, 16.5 inches of deflection.
You can see under the bridge, sensors. The sensor is measuring the information reflection. Also, we have measuring gauges, measuring the strain. You can hear the noise of carbon fiber. Pre-stressing is like spraying inside the concrete. So you have to pre-stressing strands, pushing the concrete together.
And right at 180,000 pounds, we have our first failure mode.
Are we in your way? We're in the camera's way. We don't want to miss the moment of truth here.
And the second carbon fiber strand.
182,000 pounds.
So that's the note right there.
So the idea behind the test is to demonstrate the confidence in the design, confidence in the materials, and the ability in that to design the bridge that will last for 100 years, that's no corrosion, and minimum maintenance, and shovel-ready kind of project that can be implemented anywhere, not only in Michigan, but basically we want to implement it in the South End area as well. So I hate to see the bridge failing, to be honest with you, because it's part of you. Every day you come here and look at the stresses, the strain, and argue with the students, are we doing right, are we doing wrong? And we have to build another one. So very soon it's not another one.
But the thing is, it did not break.
What's that?
It did not break.
The carbon fiber, the sound that you heard, some of them ruptured, some of them still there, and that's why we moved the load, slightly came up with the project. But it did not have a sudden
Snap.
It does not have a catastrophic failure. So we have here.
So have you developed a monitor so like when it starts here, something
Somebody at MDOT goes, uh-oh, we had a cable snap.
We have 5 bridges right now for MDOT. They have been monitored in the field. And send results every 3 months. Hey, Matt. Matt. Can you come for a second? That's okay with you, Director?
But it's an observation thing. It's not you don't have a panel somewhere that's electronic board, a monitor system.
Oh, we have that. We have that. Yes. We are talking about the monitoring of the 5 bridges. That
Yes.
we built. And
So how
we
is
sent-
what does that, is it an alarm, is it a signal, how do they know you got a snap?
Well, so this is a very extreme case, right? So if you picture it, 180,000 pounds over 2 points of load, okay? That is more extreme than any freeway condition. Legal loads in Michigan are 77,000 pounds over 11 axles. So a situation like this would never be repeated in the field. What we do in our measurements is we're more concerned with thermal fluctuation on bridges. The live load itself isn't a major load. You got the sun beating on a bridge deck, right? It wants to expand, while the underside of the bridge is at a nice, comfortable 70 degrees. And you get this constant cycling of stress. That's what we measure. We do measure deflections and we do measure loads, but they're so minor compared to the capacity of the bridge because of the way the safety factors we build in. So this type of a situation, we would never have a scenario where it's deflecting that much, and then we say, we better read the data, right? If we get something like that, bridge is closed, then we figure it out.
So you have a control room list where you're monitoring these numbers?
Yeah, actually there's a website set up. Dr. Grace can download the data, anybody can download the data that has access, and we analyze it from time to time. We've actually built in some of the analysis into the design codes that we use. And then we have other bridges in the state that we monitor certain things, more specialty details and stuff.
Now, Dr. Grace, you actually put sensor points on the bridge. So I'm trying to talk to you. So
Okay.
do you have sensors on there that is monitored somewhere? Because I know we implemented that on the bridge.
Yep, so what we have is when we fabricate the beams, when we actually pour the concrete, we give the fabricator a plan that says, put a sensor here, put a sensor here, and then they run the wire in, right? And then we connect it to a power supply.
Because I know we did that.
the last bridge. Yes. Yeah. So on your phone, you can just dial the number and look at the data. And the last bridge we built was I-75.
Yep.
And we brought 2 heavy trucks. Heavy trucks. And we tested back to back, side by side. And as Matt said, we look at
All right, can we move to the remarks?
Thank you. Thank you, sir.
Are we on? Thank you. My name is Mark Brookie. I'm Executive Director for Industry Partnerships, and while we get seated here for our remarks, I'm going to go ahead and play this video from MDOT that gives a little bit of a additional overview of the bridge that we just saw and the construction that we have. So roll the tape, please.
Michigan's bridges have a big job to do. Besides bearing the usual heavy traffic loads, bridges here must also endure fluctuating temperatures and a range of environmental conditions. Everything from dry, hot summers to long, cold winters, and lots of freezing and thawing in between. These extremes are naturally tough on concrete, causing tiny cracks to form where water and de-icing chemicals can infiltrate. For a bridge with steel reinforcement susceptible to corrosion, that can mean a shortened lifespan and early repair and replacement. In light of these challenges, MDOT changed its approach and began to reevaluate every aspect of bridge design and construction, including the materials it had been relying on for decades. The goal? To build a bridge that will last 100 years with only minor maintenance.
About 2009, 2010, that's when we started the design of our first bridge using carbon fiber strands or carbon fiber tendons as primary load carrying members.
Carbon fiber reinforced polymer, or CFRP, is strong like steel and can provide similar support to the bridge's structure. It can be manufactured into cables of varying thicknesses and added to the bridge where steel would traditionally be used. What it doesn't have, however, are steel's limitations.
When we look at how bridges deteriorate, whenever you see concrete that has spalled, it's typically because moisture has gotten to the rebar begins to corrode and expand volumetrically, which puts a outward force onto the concrete, which eventually causes the concrete to spall off. That is not a phenomenon that is experienced by carbon fiber. Carbon fiber is it's non-corrosive, so you have an element that's just as strong as steel, and it doesn't corrode like steel. And so that is how it actually behaves superior to steel in certain applications.
Michigan is recognized as a national leader in CFRP research. In fact, the first bridge in the country to be reinforced with CFRP was built in Michigan in 2001. But MDOT wanted to take the research further to understand how CFRP would last long-term under extreme stress. Working closely with Lawrence Technological University in Michigan, MDOT commissioned a groundbreaking 4-year study on 0.6-inch diameter strands of CFRP.
We built beams and we tested them to failure. We tested them in an environmental chamber at extreme temperatures below zero. We tested them in a fire chamber at extreme temperatures that would cause collapse. So we really did all of the mechanical and structural and environmental testing on these 0.6-inch diameter strands to show that we could substitute those for traditional steel strands in pre-stressed concrete beam bridges.
The efforts paid off. Using the data collected, MDOT developed more detailed specifications that make designing with CFRP easier.
So having that as a tool for our designers to use, if we wanted to do a quick comparison of I could do this beam at this depth with carbon fiber, or I could do this beam at this depth with steel. That gives our designers a lot of options to select the safest and most economically feasible design.
The project even won a prestigious national award in 2020. Now with more than 10 bridges already built in Michigan using CFRP components and an average of 2 more added each year, as well as 6 research projects on the subject, MDOT's role as a leader in this area of study has been solidified. Backed by other states interested in learning more, MDOT is continuing the research, testing thicker strands of CFRP using many of the same tests as before to develop all new specifications for new bridge designs.
The 0.7-inch diameter strand is a larger strand, which means we could put more force into it. And the ultimate objective is to have fewer strands in a beam. So if you needed a certain force that required 30 0.6-inch diameter strands, well, you would need anywhere from 23 to 25 0.7-inch diameter strands. And when you're talking about beams that are 100 feet long and you have that many strands, there's some significant cost savings that can be realized. And we really feel that that'll be a game changer, because that is really a one-to-one replacement, the steel strand to carbon fiber strand.
While CFRP outperforms steel in many ways, it costs more up front. But if using it means eliminating bridge repairs for 75 or even 100 years, MDOT says the initial expense will be worth it in the long run.
It's my generation now that is designing and building these things. We may not necessarily see the benefits. It'll be subsequent generations that don't have to deal with rehabbing and replacing these bridges until much later in their service life.
For more information, please visit Michigan DOT's website.
Dr. Verinder Madgill, Lawrence Technological University President.
Thank you, Mark. Greetings, everyone, distinguished guests, colleagues, friends of the university. I thank you for engaging in today's bridge model test. What a feast it was to the eyes and ears that you heard the drums. What you're going to witness today, or have it witnessed, is an event of historic importance to this university, to our community, to the state, which is in partnership with Lawrence Tech. The topic of the day is also the topic of the nation. These days, the health, economy, and the safety net of America builds on infrastructure, and we're doing it. The education and research conducted by our faculty and students, and especially of civil engineering leader Nabil Grace and his team, you are about to hear and listen to how these are reflected and represented of very essence of Lawrence Tech, that is theory and practice. Students learn the theory, they practice right here in this case. At this time, I have a great pleasure and an honor to be inviting to the podium Dr. Doug Ebert, the chairman of the Board of Trustees of Lawrence Tech, to offer you welcome to the campus and to this event and say a few words about the event. Mr. Chairman.
Verinder, thank you very much. My comments at this point in the program are going to be very short, which is to say thank you all for being here. This was a most interesting demonstration. I think I feel sorry for Nabil. His baby is broken, but he gets the opportunity to build a new one. So with nothing else that I've got to say at this point, I will come back to wrap things up at the end of the program. Thank you.
Thank you, Mr. Chairman. Now, I'm happy to see many friends and partners here today, so please allow me a few minutes to acknowledge our guests. Longtime mayor of this great city and now U.S. Representative Brenda Lawrence, a friend of Lawrence Tech. Representative Lawrence, Legislative Director Zach Weber. Zach, thank you. Zach Weber. Michigan Department of Transportation, MDOT Director Paul Ajeba. Paul, thank you. Also from Michigan Department of Transportation are Rick Liptak, Chief Bridge Construction Engineer. Rick, you're here. Thank you. Crystal Larkins, Metro Region Bridge Engineer. Crystal, thank you. Jeff Granson, Director of Communication. Thank you. And I'd like to extend a special thanks to a great collaborator, champion, and a partner, Matt Chynoweth. Matt, thank you. Matt is the Chief Bridge Engineer and Director. You heard him speak earlier, and Bureau of Bridges and Structures. Thank you, Matt. State Representative Kyra Bolden informed she has some pending issues, so we'll hear from her at another time. Oakland County Executive Dave Coulter. The county executive has a lot of history with this university, but it's spaced between some years. Thank you. He's a family friend of Lawrence Tech. And we have Oakland County Deputy Executive Sean Carlson. Sean, thank you. Southfield Mayor, do we have the mayor? Yeah, that's a tough job, isn't it? He's dealing with a growing city in all areas of dimension. I'm also glad that LTU leadership is joining us today as well. Dr. Tariq So, Provost and Chief Academic Officer. Tariq. Linda Height, Vice President, Finance and Administration. Linda. Of course, Dr. Nabi Grace, Dean, College of Engineering and Director. Mark Brookie, Executive Director, Industrial Research and Business Outreach. Greg Cassione, he's Special Assistant to the President, Philanthropy and Alumni Relations. Renee Tembo, Director of Public Affairs and Marketing. Renee, she is now the Interim Vice President of the same department. Now, introduction. It is my great honor to introduce our long-lived friend and someone who has been with us since the day one of the department and deployment of carbon fiber reinforced polymer bridges. From her time to Southfield, City of Southfield Council, to the Southfield City's mayor, and now distinguished Congresswoman, please welcome Lawrence Tech friend and supporter, Congresswoman Brenda Lawrence.
It is so good to be here. I just want to say to all the LTU staff, thank you for keeping my name in positive light. You know, I try to make your university look good with my name, and you do the same for me. We're partners in this. I want to say it's proud to represent the Michigan 14th District, which includes this amazing, amazing center of excellence. Many of you know the story. It was Dr. Nabil Grace, who, this is his baby. He has watched her grow. He has nurtured. I made a comment earlier. If there's a rabbit sitting in a field chewing on a carrot, and that rabbit can help move this project forward, you will see Dr. Nabil Grace in suit and tie, eloquently dressed, sitting in that field talking to that rabbit. We've got to work together. He has left no stone unturned when it comes to supporting and advancing this. And in order for a brilliant person like Dr. Grace to lead this effort, he needs the support of leadership. And Dr. Mangel has just been an amazing leader. He came into this, and we just had Bridge Street Bridge and all the advancement and partnerships, and with our former governor, our current governor, you've seen the support and advancement that we have. I saw this facility grow, and I just saw the new addition, the Army Corps of Engineers. So this has been all hands on deck. I come from Congress, and you all know from my days as mayor, saying we need to fix the roads, we need to invest in our infrastructure. Now in Congress, having served on infrastructure, transportation and infrastructure, serving on appropriations, with THUD, Transportation and Urban Development, the importance of our investment in infrastructure has not waived at all. It's only been advanced to a more critical state. And so when we see partners here, our state, our county, our municipal governments, and the scientists and other partners who are here, it's all hands on deck because we are in a crisis. And to see that we are advancing technology that's going to take some of that financial burden that we budget for. Our bridges are falling apart, so we need to program and allocate X amount of dollars to, God forbid, prohibit any of the catastrophic situations that could happen. Our director of MDOT here has been a person who knocks on my door in Washington, who has been responsive and on board. That means so much to me. But I want you to know that the Department of Transportation and also in Congress, that we know that we have a lot of work to do. I am hopeful that while we're making sausage in Washington, that we get this transportation bill passed and that you all can fry it up in the pan here locally and that you can get the job done. I'm thrilled about breaking this bridge. I'm thrilled about seeing the stress points and seeing the advancement of technology so that now when I see crumbling concrete, I'm in a panic mode. Now I know that I have the time to invest the scientific research and all hands on deck that we can fix our infrastructure without it hurting us. So for everyone who's had a hand in this, whether you appropriated the funds here locally, whether you have been involved in getting the students, and let's give a hand to all the students that have been involved in it. I was just sharing with someone watching this happen. Think of the generations of students who have been involved in this technology. And that's something Lawrence Tech does better than anyone, and I know I'll get beat up for this, but I know firsthand the seed that they plant in their students to go out in the world and advance it through technology, through research, the permission that they're given in these walls to be creative, to be innovative. Dr. Grace, you know, he's a brilliant man, but he's confronted constantly by the students who he teach to move a little bit further, to open his mind, and he has embraced that all the way. So for everyone, thank you, and thank you for naming this university after me. I promise to keep doing good.
Well, thank you, the university founder, Lawrence. Thank you. Seriously, thank you very much. We are in debt of all the support she's given over the year to Lawrence Tech and now in this project. So we appreciate her being here and spoken so supportively about what we do here. LTU and the Center of Innovative Material Research, as we call it CIMR shortly, is an MDOT Center of Excellence. Some of you know that. Here today is our great partner, Michigan Department of Transportation Director, Paul Ajewa. Did I say correctly, sir, your name? Thank you. And with that, I invite him to share his thoughts on this event. Thank you, sir. Please.
Good afternoon, everybody. First, I want to say thank you for inviting us here today. I want to express my sincere gratitude to Dr. Grace for his commitment to research. I tell you, my first experience with carbon fiber was about 2011 when we reconstructed Southfield Freeway and we put it on Pembroke over Southfield. And one thing I will say, we have a lot of contract with all the institutions in Michigan on research of different kind of issues. I think this is a major breakthrough. As I think Matt said in the video, we will not realize the importance of this in our lifetime, because what this does is it cuts down on the maintenance and it expands the lifetime of the structure. But I bring you greetings from Governor Gretchen Whitmer as well. I tell people that Washington policy is finally catching up with her vision of fixing the roads. Now in Washington, we're talking about fixing our infrastructure, building them back better. We've started doing that. If you go anywhere around the state, you'll see a lot of orange barrels out there. And that was because when she came in, she put $3.5 billion out there and said, go out there and fix our crumbling roads and bridges, and we're doing that. So I want to say again, thank you to Lawrence Tech for all you're doing, to helping us think outside the box on how we can do things better and also save taxpayers money in the process. So again, thank you for having us, and thank you for the partnership, Dr. Grace.
Thank you very much, Dr. Java. There was a slip earlier in our communication, so we also have with us Mr. Brad Wagner of MDOT. Brad, where are you? Thank you. Thank you for being here. We have a very strong advocate and seasoned leader with us here today, and whose father, I must add, was a Lawrence Tech alum, right? Thank you. So it's a family affair for us. Please welcome Oakland County Executive Dave Coulter.
Thank you, Dr. Mango, very much. Seasoned leader. That's another way of saying, I turned 60, so thank you. That's a nice way of saying that. But you're right. My dad went to Lawrence Tech. He was a civil engineer. I was not. He was hoping I would be, but I have a liberal arts brain and just didn't go in that direction. But we do have a soft spot in our family for this university, and I have developed a whole new appreciation for Lawrence Tech since I've been the county executive for the past 2 years. What a gem that we have here in Oakland County, here in Southfield, that I'm not sure everybody totally understands. But when you walk into this facility and you see what's happening here, and the partnership, that's particularly exciting to me, the partnership with MDOT and the students and the university and and internationally, right? Welcoming the future. I love that banner, because that's literally what you're creating here, is the future right here in Oakland County at Lawrence Tech. And I congratulate you and Dr. Grace and all of the students and everyone involved in this really exciting project. And I get excited about things, but like I said, I have that liberal arts brain. You don't see engineers get really passionate, they kind of have a different mindset. But I can hear, I heard it over here when you were explaining to me what was happening, that there's a passion in the engineers that are doing this work. There's an understanding that what you're creating is bigger than yourselves, and is something that, as we said, may not be realized fully until the next generation. But I can hear the excitement and the passion in your voice, and that gives me hope. As you said, I'm not an engineer, but the CFPR innovation it seems to me, the perfect antidote, not only for the extreme weather that we have in Michigan, but obviously can withstand a lot more than that. So the work that you're doing today, with the great work of our Pitbull Congresswoman to get the infrastructure bill passed, means that what you are doing here today could literally be all over the country and all over the world eventually when we make that investment. And so that to me is just so exciting. And I guess there's, what is it, 9 other bridges that are currently doing this, so we're like sort of the laboratory in Michigan, MDOT leading the country, which doesn't surprise me because, Director, as you've said, Michigan, especially under this governor's leadership, has really leaned in on infrastructure. I've been a little distracted for the past 18 months on COVID, but I'm glad to see that Lawrence Tech and MDOT are still focused on fixing the damn roads and bridges while the rest of us have been busy doing other things. And so I just want to applaud you all for the work that you're doing here. I'll be a megaphone for the great work and research in particular that you're doing here. And I just thank you so much for the invitation, and congratulations, everyone. Thank you.
Thank you for your leadership, Dave, if I may call you so. I will now like LTU Board Chairman Doug Ebert to join me at the podium. We have heard about the great collaboration and partnership between Michigan Department of Transportation, Federal Highway Administration, county, and other Department of Transportation partners here. But to talk about the importance of what we're doing, I invite Chairman Ebert.
Well, ladies and gentlemen, again, great to have you all here. These demonstrations that you see have been fascinating. So I'd like to kind of conclude all that with an important announcement. As you know, Dr. Grace, our Dean of Engineering, is the founding director of Lawrence Tech Center for Innovative Materials Research. He's also founding director of the Michigan Department of Transportation Center of Excellence for Infrastructure, and which has been significantly funded by MDOT and the Federal Highway Administration for many, many years. The Innovative Materials Research Center here is one of this nation's, in fact, the world's largest and most comprehensive infrastructure laboratories ever. The equipment that you see here exists nowhere else. This is it. This is unique. It is all here at Lawrence Tech. And the research that Dr. Grace and his students have been doing for the years is resulting in massive improvements in the durability, the safety, the life, and ultimately the cost of our infrastructure environment, particularly the highway bridges. He's received dozens of federal, state, and private research grants, totaling very, very close to $28 million so far. His work has attracted new industry to this state and to this area, and created new pathways of opportunity and success right here in Michigan. Those grants and the funding that Dr. Grace achieves has helped finance the construction of this center, the purchase of our state-of-the-art testing equipment that you see here, the environmental loading chamber and the fire loading chamber. These facilities are all being used to conduct hundreds and hundreds of tests over time, aimed at trying to improve our infrastructure for us. The work that he's led here on composites for bridges, which we've talked about quite a bit already this afternoon, is expected to double their lifespan and virtually eliminate the issues caused by corrosion and salt and other chemicals, which we know all too well here in Michigan. Just as important as the educational process at this university, the testing here has provided for hundreds of Lawrence Tech students from the bachelor's level to the doctorate level, with hands-on, real-world experience to help prepare them for their careers ahead. So you're probably wondering, where am I going with this? Well, let me tell you. To recognize Dr. Grace's remarkable achievements, our Board of Trustees has resolved to name this amazing facility the Nabil Grace Center for Innovative Materials Research. That's why I'm here. We see this center as a fitting and permanent tribute to an inspired teacher, researcher, innovator, and technology leader. Dr. Grace, would you please join me up here? I have nothing else to add. I think I've done my job. Well, thank you very much.
Thank you, Mr. Chairman. Ladies and gentlemen, distinguished guests, everyone who participated viewing it or participating, we are very grateful for your presence, your support, and your good wishes for this institution, student, faculty, staff who work very hard and bring these massive piece of equipment so we can do some work with theory and practice. So thank you. We have some refreshment. Please do share that in the next room. At this time, I will say that Nabil Grace is the star today, and we wish him good health because the state and the community needs things like this so that we can live in peace and drive through or under the bridge without worrying about the concrete is falling on us. So congratulations, Nabil, and thank you for being here.
Yes.
once again.